Hello and welcome to this new lesson in which we are going to talk about the bitwise operators. Now, the bitwise operators are used to manipulate bits inside C language. Now, let's start with the AND, OR, XOR, and NOT. As you can see from these tables, when you see the AND sign, this means that whenever there is 0, the result will be 0. So if we have two operands, A and B equals Y. 0 and 0 will equal 0. Since here we have a 0, it will equal 0 as well. And since here we have a 0, it will equal 0 as well. The only time that the result will be 1 is when both of the operands is 1. So 1 and 1 equals 1. When it comes to the OR table, now let's talk about the OR. Now when it comes to the OR, you will usually see this sign between the two operands A and B. Now for the AND, you will see the AND sign, so it will be A and B. In case of OR, whenever you see 1, the final result will be 1. So here we have a 1 and final result will be 1. Here we have 1 and the final result will be 1. Here we have two 1s, this one and this one, and the final result will be 1 as well. Now the only case that the result will be 0 if there are no 1s at all, neither A or B are 1, so the final result will be 0, which is basically the opposite of the AND, almost opposite. Okay, now for the XOR, as you can see in here, the XOR is basically this sign. So A XOR B. In this case, if the two operands are similar, the result will be 0, as you can see in here and in here. If they are different, the result will be 1. Now, the last one, which is the easiest one, it's the NOT sign. The NOT sign is a uni operator. These are by operator because they take two operands, as we already mentioned, and this is a uni operator, so you'll see not A. So not means the inverse of A. So if it is 0, it will become 1. If it is 1, it will become 0. That's it. Now let's see them in action. Let's say that we have two values, x and y. X here equals 1, 0, 1, 0. Y is 0, 1, 0, 1, and these are called binary values. And we can talk about binaries at the end of this course. Now, these two are the two values that we will do these operators on. We will do AND, OR, NOT, and XOR. Now, when we are doing the AND, X and Y, the final result will look like this. We already mentioned that the AND sign means if there is 0, then the final result will be 0. So when we are talking about the AND, 0 and 1, we can do this to see the value. 0 and 1 will equal 0. 1 and 0 will equal 0. 0 and 1 will equal 0. 1 and 0 will equal 0. So the final result here will be 0, as we saw in the truth table. Now, regarding the OR, we already mentioned that this is the OR sign. Now, if there is 1, then the final result will be 1. So 0 and 1, 1, 1 and 0, 1, 0 and 1, 1, 1 and 0 will also equal 1. So it will be either a binary value of 1 for 1s, or we can convert it to a decimal value using the calculator. Now you can change the calculator to programmer and you can enter the binary value 1111 And as you can see, the decimal value is 15. So this equals 15. Now the not sign is straightforward. Not x means this is the sign, not. So not x means the inverse of x. So it will be 1, 0, 1, 0, since x equals 0, 1, 0, 1. And we can use the calculator to convert the value. We can write 1, 0, 1, 0, which is the original value. It equals 10 in decimal. So let's write the new value. Okay, it was written incorrectly. Now let's add 0, 1, 0, 1. As you can see, it equals 5 in decimal. So this will be 5 in decimal. I need you to memorize these values because we will do this in a practical way in a few seconds, and we need to know the results. Now, x or y, we already mentioned that if they are both identical, then the value will be 0. If they are different, the value will be 1. Since all of these are different, 0, 1, 1, 0, 0, 1, 1, 0, then the final result will be the same as here, 1, 1, 1, 1, which equals 15 in decimal. Now we can do a lesson about numbering systems, but this is like a prerequisite for this course. That's it for the bitwise operators. Now, to make things more clear, we need to take a quick example. So let's move on. Now, let's start by writing our include. Void, as usual, main void. Change the language to C. And in here, we need to define the values. So int x will equal the binary value of 1010. If you wrote it like this, it will treat it as a decimal value. So to make the compiler understand that it is a binary value, you need to write 0b. 0b means binary. This is the prefix for the binary. Now we need to add y as well. So 0b 0101. Now once you are done, we need to start defining new variables. Int and operator equals x and y. Int or operator equals x or y. Int XOR operator equals x, the power of sign y, and not operator equals not sign x. Now let's print this out using a printf function. So I will write them as they are, equals %d, and let's add the result here. Add /n here, copy this line, now paste it here, and paste it here. Change this with this, not operator. Change the XOR operator and the equation. Change the OR operator with the equation. Now let's save it. Bitwise Operators. And let's try to run this. Now let's zoom in. GCC C a.exe. Now, as you can see here, we have 0, 15, 15, which is something we expected. And here we have minus 11. Now, let's talk about the minus 11 here. Now, at this level, we won't go into the depth of the minus values, but let me show you on the calculator what will happen. Now, the value is 10, 10. Once you choose the bitwise NOT operator, you will see that the decimal result will be minus 11. And this is because the 1010 are not treated on their own. The binary operation NOT is done on all the bytes that are left. So yes, you did write 1010, but the rest of the bits were written as zeros. And in this case, the NOT will reverse them to 1. Now, in the coming lessons, we will cover the negative values and how to print them and how to interpret them inside your console window. But at this point, what you need to understand is that when we did the NOT function, we did it only on 4 bits. We didn't take into consideration how many bits or bytes the compiler will assign for the NOT operator. So, if it has assigned 1 byte, then the final result will be 10, 10, 1, 1, 1, 1. Because 1 byte means 8 bits, and the original value is 0101. These are only 4 bits. There is also 4 zeros that are hidden here. So we'll convert them to 1. Now, other compilers assign 4 bytes for an integer. And in this case, we will have 3 more bytes of 1s. That's why this is an advanced topic, and we will cover it in the coming lessons. Now, if you reach this point and you are able to apply the AND, OR, XOR, and learned how to apply the NOT operator, then you are good to go. Thanks for watching this lesson. Next, we will talk about more bitwise operators that are advanced and used in bit manipulation. But that's it for this lesson. This is Ashraf from Educational Engineering Team.